Loved it. Anyway, let's shut up. Okay, here we go. Okay, so I gave him time to do bell work, and then we're going to go ahead and do this super fast. Okay, listen. All right, so this is sine of x over or times 1 over cosine. And I'm going to make this real quick. This is sine over cosine, which is tan. Everyone should have got tan for this one. How many people got that right? Should be everyone. All right, sorry. Next thing, what's 1 minus sine squared? Say it out loud. Okay, it's third hour. I knew that was going to happen. All right, and then you know what? I'm going to make this 1 over cosine right away. And then we should know that these cancel like this. So the answer is cosine. How many people got cosine on that one? These are just little layup ones, but they're nice. We have these like on a test, like quick. This would be like quick multiple choice, you know. So we do this from once in a while. This is what you should do. It's actually talking to one of the other teachers. I forgot which one. People trying to make this in terms of sine and cosine and all. No, what's sine squared plus cosine squared? I told you the most beautiful thing. What is it? 1. Then you know what 1 plus cotan squared is? It's cosecant squared. It's the other trig identity. So I know you don't have them in front of you. I know we just did this yesterday, but this is the idea, how these break down and how we substitute one step to the other. Okay, so you got to get these Pythagorean identities down. Might be a nice time to think about this. When you're doing these things, you might put this up at the top. And as long as you know circics or ticks, you know, I think I forgot to do this in the other hours. That last minute, like how do I know all three of these? Well, at first, maybe I'll get rid of those first. Divide by x squared. 1 plus tangent squared equals r over x secant squared. You know, and then you could cross this off and then divide by y squared. X over y is cotan squared plus 1 equals r over y cosecant squared, or divide by r squared. Cosine squared plus sine squared equals 1. So that's the quick way of deriving these, so then you can use them and then you can see why I got this answer. So those are the hardest ones. I saw which group over there and I got confused. It was that group over there. What is that times that? What is that times that? I put this on our notes yesterday. And it's a big fat 1. They put that, I'm like, why did you? Oh, right. I told you that whenever it's sine times cosecant, it's 1 because they're reciprocal identities. I don't need you to write that as 1 over sine. I don't need that. You should know the reciprocals, so you should know that they equal 1, and you should be able to write that quickly, meaning I should allow that and let that be the case. And then what is, ooh, I don't like this, and I just yelled at a couple students there. We're bad. There should always be an angle measure there, so always write your angle measures. And then this is tan. All right, because 1 over cotan is tan. How many people got tan on that one? Hey, how many people got 3? A lot of people get 3? Nice. Okay, what's secant squared minus 1? No, it's not always change it into sine or cosine. It's a Pythag. Well, the Pythagorean identity is 1 plus tangent squared equals secant squared. I subtract 1. I lost my pen. This is where I start thinking we're going to lose this video too, because that happened yesterday. That's tan squared. This is true. Okay, so I don't want to like make this too. Yeah, I already said it verbally, which is how people say things verbally. Anyway, and then you know what I'm going to do? This is times tangent. That, you know, what did I say about cotan on the bottom? It becomes tan on the top. All right, I don't know. I'm just kind of writing that weird, but maybe I'll highlight that so you're not lost about how I did that. That cotan on the bottom becomes a tan on the top. That's how I told you to deal with these trig identities. Deal with them efficiently, and that's okay. What did I say about a secant on the top? What is that the same as? A what on the bottom? Who's secant related to? Who's secant related to? You guys are killing me. Cosine. Oh, this third hour. Okay. What's cosine times cosine? Cosine squared. But what's 1 over cosine squared? What's the flip of that? Secant squared. So I would appreciate that you do that like that fast. Okay, so I do like the idea of just taking the reciprocal identities and flipping them right in a fraction right away. You don't have to write 1 over cosine divided by cosine and then try to get lost in the fractional quagmire. All right. All right. So I'm going to enable you and tell you again, we're now solving again. You cannot let the unit circle slow you down. So this is instantly what you should write on any single question that deals with the unit circle evaluation. Because yes, passive aggressive yesterday in the notes, how many people still are struggling on the unit circle, even though we've been on it for 2 months and not writing this? You are ridiculous. Okay, I'm sorry. I'm done with it. So, and I didn't write the angle measures. We should know that pi over 6 is first, pi over 4 is second, pi over 3 is third in that quadrant 1, and then an ASTC thing. Okay, because now what we're going to do, as maybe you're writing this down or not, is combine the last 2 days together. We're going to use an identity to make a substitution, but then we got to solve an equation, which is what we did 2 days ago. All right. And I really hope after spring break, these 3 days, we can review it when we get back and it'll be okay. But again, it only goes if you're doing your homework. Yes, I pointed at you. All right. Now, here's where we're going here. This is unsolvable right now. Remember, I told you to treat variables wrong. Treat trig like variables. And this is like being presented this equation. 1 equals x squared plus y. Meaning those are different. That's an unsolvable red equation up there in algebra 1. All right, you can't really solve it. You could get it equal to y, but then it's in terms of x squared. You don't get a number for an answer. So unsolvable. So the clue today is, or the bridge, the connection is, there's an identity I could replace that secant squared with, and lo and behold, it is in terms of tangents. What is secant squared? We already wrote this one here today. It is 1 plus tangent squared. So in your day 2 of this, maybe have the identities in front of you. The ones that really do the right thing when they're doing their homework, first of all, they have to do their homework, is not have it in front of them and then try it and then look if they're okay. But now I am in the same variable. This is like 1 equals 1 plus x squared plus x. I could solve that. That's a quadratic. But watch what happens when I subtract 1 from both sides. And now we're in, and now I'm gonna yell at you for our last quiz. How many people nonsensical factoring work? Oh, they're killing me. And I am gonna be that way. I don't care. You've got to be able to look at this. Oh, I'm using too big a space here. So I'll slide this over here. You got to, I lost my pen again. Love the randomness. Love the randomness of what I deal with on a daily basis. Tan of theta is a GCF. Good distributors, good factors. Tan times tan is tan squared. Tan times 1 is tan. That's exactly what I have up there. But don't redistribute that. Just you're checking your factored answer. Does it make sense? And I still have people that cannot do this. All right. I have really bad spatial issues here. So I guess I'm gonna be a cowboy, baby. I guess I won't, because my pen's not working again. I love life. All right. Yoink. Or yeehaw. I forgot to say that. I'm slipping. All right. Now, zero product property. Tan of theta equals 0. Tan of theta equals -1. Okay, so I set that equal to 0 and subtract, and this is exactly what we did Monday. I'm going to tell you right now, we are now in Monday right here. So to get back what is going on, one step gets to what we did Monday in the notes, and that's what we did. We solved an equation like that. So you got to be able to just get that one step done, use the identities, and then be able to solve an equation like we did Monday, and I hope you're there. All right, and that's why that's the only big deal. And then you could go to this. I think it said tan of theta equals 0. And then I'm going to show you how to use this because I still think people don't know how to use this, and it makes me sad. It does. Okay? Don't know what's going on out there. All right? But tan of theta equals 0 as a ratio. Well, that would have to be here because it's y over r. So that's at 0. And y over x. I said the first one wrong. Y over x. So that's at 0 and pi. What was the other one? 1? Was tan of theta equal 1 or negative 1? Negative 1, that's this one, root 2 over root 2. That's the over 4s. But it's a negative 1. I forgot one more thing to put on here, ASTC. Okay, so we're actually in quadrant 2 and 4 for that other one. So going back to that, that's how you use that and look at that. For 0 over 1, it could be plus or minus. That was theta equals 0 and pi. And then those over 4s in quadrant 3, 4 pi over 4 fumble, subtract. And then 8 pi over 4 subtract 1. 8 pi over 4 is equal to 2 pi. And if you still don't know that, I'm sorry, you do make me sad. You are severely and totally behind, and you're like 2 months behind. Okay? And I'm sorry, that's part of what we deal with in this regular class. It is rough. We got to get up to snuff here. All right, stop complaining, Mr. S. Sine squared, sine, cosine squared. I got to make that change. This is like x squared minus y squared plus y. Unsolvable. Can't be done. So the whole idea of today, bridging 2 days ago to today, is make a substitution. And that substitution was actually substituted today in the bell work. We had 1 minus sine squared. We substituted cosine squared for it. But now we got to do the reverse to match all the other variables. And I'm air quoting that you can't see my face. Variables, trig variables. Now they're all in terms of the same trig function, and now I just have to do my algebra skills. Something I don't like about this, negative sine squared and negative sine squared is negative 2 sine squared. I don't like a negative leading term. Plus sine, I think I'm writing too large again, and then plus 1 equals 0. I got some space over to the right. I think I'm good. I don't like a negative leading term, so I'm going to multiply both sides by a negative. Negative 0 is still 0. I hate factoring with a negative leading coefficient, so I would think you guys would hate it as well. And then, guys, I am tired of this factoring killing us. People are trying to pull out a GCF or whatever. I can only keep explaining this, and hopefully at some point it sinks in. To get 2 sine squared, it's got to be 2 sine and 1 sine. That's first of FOIL. Good FOILers, good factors. And then how do I get negative 1? They have to be 1 and negative 1 here. So these are both going to be 1, but one of them is going to be negative. And I need a negative middle term. So that means this has to be negative as a product. And this has to be positive as a product. And that ends up giving me my middle term of negative sine when I add those two terms together. If you still can't visualize that, I'm going to make a bad comment again. I don't know how you're in here. All right? I'm serious. Okay, this is a math 2 thing and a math 3 thing and probably a math 1 thing. I bet you factored in math 1. I bet you. All right, so we need to get this factoring figured out, all right, and make answers sensible by checking. All right, now it's zero product property. I do have space for that over here, and I'm going to write these up here. So subtract 1, divide, and I'm not going up to the unit circle. Add 1. All right, think about it for a second. I will write what the thetas are. You try to beat me on what sine of theta equals negative 1/2 gives you as angle measures. I'm going to talk out loud. I know it's an over 6 because I heard someone a million times ask me, what's sine of pi over 6? Half. All right, that somebody's me. And where is sine negative? Quadrant 3 and 4. And then where, you don't have to necessarily go in order here. Where do you get 1 for y? R is 1. That means x would have to be 0. Where's 0, comma 1? What angle measure? Oops, sorry. Someone said it, and then I don't know why I was writing 3 pi over 2. That'd be if it was negative 1. So it's at pi over 2. And I said I wasn't going up to the unit circle. I want to get this done because right when I get to the 20-minute mark, the video may die. This is a really weird one. I know what Mrs. Oh, gosh. All right, and then you guys, I want to cover this now because I talked to Mrs. She's a AB and BC calc teacher. Some of you may get her next year. I always say she's like the best math teacher in this building. She likes squaring both sides on this one because she's afraid that students don't understand the difference. Like when you have a question like this, just write this real quick. When sine times cosine, I just put a 2 there just for giggles. When I get students to do this, you lose an answer. This is a disaster. This is bad. You should never do this. This is why she doesn't like what I do next on this one, which is actually legal. This is illegal because you actually lose these answers. And I know I'm writing a new thing here, but I like sharing, like we do talk mathematically, like why do you teach a certain way? What do you do certain things? What you need to do in this question is subtract cosine and then factor it out and then use the zero product property. This was on your test, and I did say this yesterday to you, or 2 days ago. When I did 2 days ago's notes, I brought up the problems of the last quiz, and that was one big one. So why am I allowed to divide by cosine here? It's because you don't lose cosine. You think you lost it here, but it's still here. And then just tell me, what is sine over cosine? What trig function is that? Tan. And now this is very doable. So you didn't lose something like this. This is different. That's bad over there. This is good. All right. And I want you to know the difference as I'm covering this. Because otherwise, if you square both sides, you create another conundrum. Let me just be honest. It's a problem. And this is very direct and very fast. Where's tan of theta equal 1? I think we've already talked about that. It's highlighted over there. What angle measure? Pi over. I got Chewbacca in here. It was over 4. Maybe that's a 4. And then what other quadrants? Drink time. Quadrant 3. That's 5 pi. I actually had to think about that for a second. My brain was locked. I'll ignore that comment. A non-homework doer over there. Okay, and I really don't like this one, but we're going to do it. All right, so let me get rid of this. This was just to make a point. This was not an example. I wanted to show you why it's okay sometimes to divide by trig, and sometimes it's not. All right, and that was the whole point of that. All right, I got this and I got this. This is like x squared negative x squared plus 2y squared. Unsolvable. But I do know this one. It goes back to this one up here. If you're looking at this, those that have real good visualization, if they could just see these letters, cotangent squared is x over y. So cotangent squared, plus, here, I'm pointing in the class, but I'm going like this. I'm focusing on this when I divide by y squared. That's cotangent squared plus 1 equals cosecant squared. That's how your brain looks at this, so you don't necessarily have to have it memorized. You can keep deriving it right in front of you, right? And then use it. So what did I say? Cotangent squared plus 1 equals cosecant squared. So this is cotangent squared theta plus 1. And then there's a 2 there. And then there's a negative cotangent squared there. So now you have the same variable. That's the whole point of this lesson. One step using one identity to get it to Monday, which is what you've already done. If you've done your homework, that's a big if. And that's the big problem with teaching in America today. Now, I hope you can handle this. 2 cotangent squared plus a negative cotangent squared is 1 cotangent squared. This is another thing that scares me about the algebra and me skipping some steps. This is 2, then I'm going to subtract 2. That equals 3. Okay, so I did distribution, and then I added like terms, and I subtracted the 2 across. Sorry if I went too fast on that. I'll let you a minute to think about it. What do I got to do when I have squared, though? What's the opposite operation? Square root. And when I square root both sides, yes, he's raising his voice because I'm sick of this mistake. One person in the quiz did this, right, Lexi? You made the internet. You can sue me now. I didn't say your last name. Go ahead, go for it. I'm trying to get fired anyway. I don't care. I don't care. People are coming after my job anyway. He said this today. All right. What am I supposed to do, Lexi? You tell them. Plus or minus. She was the only one to do this on the quiz. Every single other person in this classroom missed 2 of the answers. Everyone. And that same thing happened fifth hour. Now, fifth hour was worse. What? The glorious fifth hour? Um, I actually told them, I warned them right before that test because I saw the results in third and fourth, and I said, hey, class, what do we do when we square root? They all go plus or minus. Then they take the test and they all got it wrong. So it didn't even stick. Nothing. It is. All right. Hey, who is that? Is that a 30 or a 60? Is that an over 3 or an over 6? It's one or the other. Over 3 or over 6. I know what it is because I know what y is opposite. It's always opposite the reference angle. Who's opposite 1? Is it 30 degrees or 60 degrees? Guess what? 1 is smaller than root 3. Which angle is smaller, 30 or 60? Does anyone know what I'm talking about? I know. What is happening in here? The answer is 30. 30 is smaller than 60. 1 is smaller than root 3. Got it? So 1 is opposite of 30. This is the over 6s, and it's every single one of them. That's the glory. I lost my pen. I love it. I hope the video doesn't finish too. I hope it like dies right now. This would be great. Come on, do it. Do it again. Add to my insanity of dealing with this computer. I think we made it. We did it. Have a good day, everybody.